So the first thing that we need to do in analyzing any statics problem, as any engineering student can tell you, is you have to be able to draw a free body diagram or an FBD. And so if we take just a very simple case, which is our simply supported example, and let's just throw some arbitrary load on this thing. Maybe there's a point load here, and we could have a concentrated moment on there. We do something called the WISE methodology for drawing this. Okay, and these are the types of forces that have to be included on any free body diagram. Now, we know that for our free body diagram, if let's see, change this color, say, to a red, then we know that a pin support would have a vertical and a horizontal reaction. Here's my H, there's my V. And then we would have a roller would have one perpendicular to its support, which would be, that would be a V2, this would be a V1, or something like that. That would be our general free body diagram. And it's this picture is what we need to be able to set up our equilibrium equations to be able to start solving for things. Now, before we can draw our shear moment diagrams, we have to be able to find support reactions. And so for now, if we have, in this case, this is what we call a statically determinate. See if I can get this back to black. There's some terminology to get out of the way here that we have. You'll see this expression used a lot. All right, means that I have, if I start looking at my equations of equilibrium, which for a 2D problem are sum of forces x equals 0, sum of forces y equal to 0, and then sum of the moments about the z equal to 0. Again, assuming that my coordinate system is y positive up, x positive this way, and z would be positive counterclockwise. That would be kind of our typical sign convention that we use when analyzing this. So statically determinate means that I can use just these three equations and be able to find everything that's unknown about the system. In this case, I can find all of the red items. Now, one of the problems that we have is trying to figure out, well, how do I go about writing these equations? Okay, so to be able to do this, I have to be able to draw the picture. The first one in our WISE methodology is our self weight. Okay, I is internal forces. S is support reactions. And E is our external applied loads. Okay, which would be, in this case, it would be my P here, my W here, and whatever else, our M naught moment that's applied there. All of those would fall under the external loads. Now, the first one that we always write in analyzing this problem is we draw a picture in which we cut nothing. So this guy goes away, the I goes away. Okay, and self-weight is generally pretty negligible, so for now we'll leave that off up here. So the only thing we have to worry about is coming up with a system to be able to handle support reactions and external loads. Now, so far, we know how to draw them on the picture, but we don't know how to actually do the calculations, and so we've got to kind of come up with some strategies to be able to kind of figure this out. All right, now, if we look at this, all is fine and dandy on our beam here, especially if we know that this length is L. I can write my equations for this particular picture. It's not too bad, really. We could write, sum of forces in the X equal to 0, to the right positive. This tells me nothing because there's no horizontal forces except that, whoops, it does tell me something. I got ahead of myself. Okay, that we have an H. All better be equal to 0 because it's the only horizontal thing. So we found one of the H's. Okay, if I go and write sum of forces in the Y equal to 0, upwards positive. Okay, now I've got V1 plus V2 minus my P, and we would have to have, missing a couple dimensions on here, obviously, aren't we? Let's call this length of the W as, L1, and then we could say that this guy is starting at some, L2, up there. Okay, then this is minus P minus W times L1, all better be equal to 0. Now, again, I don't know V1 and V2 at this point, so this is an unsolvable equation, but the relationship is true. Whoops, try not to slide that around too much. All right, so then we're left with our moment equation. Okay, and let's go counterclockwise, positive. Slide that up a little bit so we can see what's going on here. Okay, and so if we choose to sum moments at what would be our A location, which, we're calling this as A, and we're calling this as B, and that'll be the sign convention that we use most of the time in analyzing these particular problems, A on the left, B on the right. Okay, and so now I can do my moment equation on this that would say that V2 times my length L, okay, that's a positive because it's in the direction of what I assume counterclockwise. Okay, I have a minus my M naught applied moment because that's a clockwise moment. And then I end up with a minus W times L1 times what would be L2 plus L1 over 2. And all of that, oops, not equal to 0. I got to get my reaction. V2 is there. M naught, yeah, that's everything. So all of this is equal to 0. Okay, and so that would be my basic equation. And so our idea is that we've got to come up with a way to be able to build all these different terms on here. Okay, now here's the problem that we're looking at, and this is one of the challenges that I knew was coming into this thing. What happens if we define a beam as a node to a node to a node, and I have an intermediate node, and now say we have a load of a force P happening on that, and maybe I have an M that's on this guy, and we could pick a bit of distributed load, but it's not necessarily necessary at this point, because what we're doing is we're assigning loads to beams, which would be the guys that are happening between the nodes. Whoops, what did I do here? That one. My hand hit it. All right. Okay. So the question becomes that when we start writing our equations, let's say that this is now a pin, and that's my roller. Okay. Again, the free body diagram, we can determine this. Here's my V1. There's my H1. There's my V2. Building those equations of equilibrium that we had up here, forces X, forces Y, and moments, still works. The part that doesn't work now has to do with the dimensions of where things are at. So instead of dealing with L2s and L1s as length of members, now we almost need to come in and start measuring things relative to our common point. So if we come in and set our reference there, then the dimensions that we need have to be, what is this guy? That's the X that gets me to the load. And this guy here is my X that gets me to the moment. So we're going to have to come up with a system that's going to allow us to be able to measure these things. Now, we know these coordinates in space. When we made the nodes, we know that the coordinates here are XA, YA. We made that one. Okay, and we know this one is XB, YB, and we know that one. So that's not bad. And if we wanted to call this as node C, then this would be XC, YC here. The problem is that we were measuring, and it's not really a problem, it's a challenge to get into there. That we measured this as, some D1 value on, beam number 2. Okay, if I use nomenclature, it looks like this. I'm going to say 1 is, I like to write my beam numbers inside of boxes so that I know this is beam 1 and this is beam 2. Here's beam 1, here's beam 2. And so the question becomes, I've got to come up with what are the coordinates for P. Okay, so we kind of got our dimension here. And so what this kind of looks like is, it looks like to me, we've got this in terms of an XA, YA coordinate, but we need to define some origin node. okay, which is my reference. Okay, and then that becomes the basis of everything that we do. Now this isn't bad. We could do, you know, XA, YA, but what happens if we start constructing these nodes out of order? I don't do XA first. Well, I can't just take the first node in the list. I've got to go find what would be then the leftmost node to be able to draw this thing. So that's an idea to kind of think about. So let's do leftmost here. Okay, now if we go through and we say, well, if I want to get to XP, then I've got to be able to know that in order to find P, I have to know all of the beams that are between him, because I can define the length of one, you know, in the X direction as being XC minus XA, and the length 1 in the Y direction as being YC minus YA. Will get me this piece. And so for our simple beam here then XP would be equal to then what would be L1's X direction, okay, plus what would be our D1 in the X direction, and then our YP would be our L1 in the Y direction plus our D1's Y direction. Assuming, now again, if this is horizontal, the YP doesn't change, and we're going to start off with the simple case where it's horizontal, but that becomes a bit of an issue because I know D1, it's the L1 guy that's related to him that I don't know. Okay, so even though the load is applied to beam 2, I've got to have a way to be able to figure out which beam is connected to which. And that's kind of our challenge for what we're looking for, kind of what beams do I have to travel along to be able to get there. So if we kind of look at this, what I think we can do is right now we have a list of beams, okay, that we've made. Okay, now I know we were using our iDrawing object item, but we do have this guy that we can work with. And so what we would have to do is we would have to, first off, we've got to find our origin node. Okay, and then we've got to search a path okay, that gets us to P. Okay, meaning that if I have, you know, multiple beams, 1, 2, 3, 4 beams in here, and I know that I start at node A here and I end at node C here, and I start at node C here and I end at D, and I start at node D and I end at B, then I've got to be able to search a path that could tell me, because ultimately what I'm wanting is to be able to define where our, you know, and then say that in, you know, that to be able to link all these together to be able to ultimately get our case. So the case we would be looking at here is, you know, let's call this as A, let's call this as C, let's call this as D, and we'll call this as B. You know, and that would be how I would define my beam. And so from this, I could build the total length of this beam in the X direction and the total length of this beam in the Y direction, and so forth and so on. And so then I could start to build up pieces and figure out, well, if my load is here, now all I need to do is add that D1 value. But if my load is here, all I have to do is, you know, is figure out what that D1 value is. So I would do, you know, my length of AC, okay, whereas this is now the length of AC plus the length of AD. And so this is kind of the challenge on being able to put the parts together. Now, we could greatly simplify this if I went through and said that I will always order these as 1, 2, and 3. That becomes one of the issues that we have to kind of look at. So, you know, that if that's the case, then building this is no problem. But if all of a sudden I'm having to search for the order or the sequence for which things go through, we've got a little bit of thinking that we have to do. And I've got some thoughts on what we're going to do with that. So we'll jump into the code and we'll start kind of working with how do I do this construction or know what's connected to what. Okay, this piece is commonly what's done in most engineering software diagrams. Okay, and we have kind of, it's either what we call an index table, okay, or a connectivity. not quite a matrix, but that's what we call it. Okay, it tells how the nodes are connected to each other. Okay, that I have a beam 1 that connects nodes A to C, and this is kind of what we were set up for back in our early videos, as we were starting to kind of lay things out and constructing beams. All I needed was these nodes. Now we've got the pieces. How do I put all this together? And that's the challenge that we're going to try to address today. So we'll jump into the code now, and we'll take a look and see what we can come up with. All right, so here we are back in the code, and we want to kind of take a look at, kind of show folks where we left off last time. We were drawing loads, we've drawn support conditions, we've got nodes, and we've got this artificially created structure that was just kind of testing our indexing and all those kind of things. Now, first thing I think we want to do is we want to get rid of this stuff and kind of start to lay this thing out something a little bit more realistic. So the piece that we want to get rid of then is we want to get rid of this guy. Okay, whoops. Well, before we do that, one thing I do want to do is I want to move this information. This information is where we were drawing our loads, drawing our beams, and all this. And I was writing it in on user create, but it's really more appropriate to put it up here in our on user update. So we'll overwrite that, and that will give us our nodes, our beams, and everything. Because all we want to do is be able to call this and then basically redraw everything if we need to. And that's what we've done here. So we can take that out. And so we can lose this. That gets rid of a little bit of repeated code. This should still work. And it does. Okay, so because we're calling our on-user create, you can see we do on-user create called once. And then this is going to be called when a redraw is needed. Maybe this is once per frame or as necessary. Okay, so that's what we're doing, is we're running into this guy, and then anytime that we add something, which we'll be adding to that, we'll just call on user update. All right, so now on user create, for now, we've got our supports, we've got our, let's see, so this is where we were auto-generating nodes and beams, so we don't need that anymore. Okay, let's go through, and the first thing that we want to do is we want to come up with a, let's see, I need a VM node, okay, that we're going to call as node A, is a new node, new VM node. Let's try that again, VM node. And if we look at our other constructor, you can see that we need an X and a Y, and then the support type that's located at this node. And so if I go through and I put so instead of putting it at 0, 0, we're going to offset it a little bit. Let's go say 20, comma 20, and let's see if our support types dot support pin, if that will show up. That will do that. Okay, and then we want to do a nodes dot add and add our node A to that. Okay, that adds our list there, and then if I copy all of this down, and let's just say we have a node B, then we'll set ourselves up here. And then we can go in and say that maybe we're just going to go to 120. That way it's 100 units long, and do this. And then we'll change our support type to a support. Support, and we want a roller X so that it's a horizontal roller, and then we're going to add B to this. Okay, and then we're going to add a VM beam. Okay, and we'll call that just as beam 1, and this is a new VM beam. And then our start node is node A, and our end node is node B. All right, and that can be the way that we can start to kind of set our way up there. Okay, and that will get us that, and then we need to, of course, add beams dot add beam 1. All right, and that will cause us there. So let's see what happens if I put all this in. Do we get a beam like we would expect? What do we do? Oh, yeah. I got stuff in here that we don't need anymore. So this is where we were artificially defining our supports before. So we don't need that. Let's try and then add that. And of course it's not horizontal because that should just be a 20. All right. And probably want to make this a little bit larger just so we can I go to 420. That'll make them 400 units long. And you can see, so we've kind of got a beam happening here with our point loads that we added on there. And point loads, why is it drawing both up and down? Where's my beam? Base load. Oh, these were, yeah, because I was testing drawing this, and this. Draw line, draw tag. So that drew the beam. Okay, we're not going to worry too much about drawing the loads at this point. All right. Okay, so there's our beam and our support conditions and everything. And again, we've got some graphical deals like this roller needs to be dropped down, but for now, we've sort of got it rolling. Okay, so that gets us to that. Now, let's think about this a little bit. Nodes. So that got us our here, so we'll add a point load on this. And one of the things that we need to look at on our load when we draw it is, do we draw an arrow up or do we draw an arrow down? So if we go to, where is our base load on this? So now if we go in, where is our magnitude? We'll set it based off of our, if W1 is less than 0, now we can do drawing helpers dot, where's our draw line? And actually, and then we're not drawing a line, we're drawing an arrow. So let's just grab, basically we want to draw an arrow down. Control C. It looks something kind of like that. Okay, else. And right off the bat, as soon as I do that, what do you notice? We have lines that are very, very similar that are only being based off of a magnitude value. And so I'm wondering on this, maybe in our drawing helpers, we can go over and do a public static void that is a draw arrow that would take a canvas C. It takes all the stuff from the draw line that we had before. Put a comma in there, put that in that. There's our stroke. Gets us our draw arrow, and now we can say maybe we need to add a, what was it? It was a load types. No, we don't want that. We need a direction. All right, so we're going to add a, let's go back in and on our drawing helpers, maybe we can add an enum here. Oops. I know I'm jumping around a little bit here and I apologize for that. So let's do a public enum arrow direction, and we could go, arrow up, set that as 0, arrow right, set that as a 1, arrow down, we'll set that as 2, and then arrow right, or whoops, not right, we want to do a left, and set that as 3. That gets us our arrow directions, and let's change that to a better arrow directions like that. And now we can come in and on our draw arrow down here, we can do an arrow directions direction, and we're going to default that to arrow down, arrow directions dot arrow down. Okay, and then we can do that. So, well, maybe we should go ahead and explicitly not let it default that out. Let's take that out. Let's do it this way. This is the right way to so. Although I do need to receive the direction, so I do need a direction. Undo. Take that, and we just won't default it. We'll require it. So if direction equals arrow directions dot arrow down, we can do draw arrow down and actually let's do it this way. Let's do a switch statement. Switch on direction. Oh, and I didn't. So why didn't you stub me out, you turkey? Oh, you're not cooperating. Switch. Well, I didn't stub it. All right. Do it the old-fashioned way. Case. We went arrow directions dot arrow down. And case arrow directions dot arrow up. And then case arrow directions dot arrow right, and then do case arrow directions dot arrow left, and that will give me that. All right, and then for now we'll set our default case to draw a circle. Okay, on our canvas at X, at Y, at fill, and at stroke. So that will be kind of our indicator that we haven't drawn the load on there. But if we do have our arrow, then we can do draw arrow down. And I can do C, just basically pass all of these variables through. Y, and fill, and stroke. Like that. And that will get me that piece. And then the up arrow is just draw arrow up, C, X, Y, fill, stroke. And then once I do this, this is a break. Gets me that one, and then I can put a break. Whoops. Put a semicolon. Whoa, come on now. What are you doing? Stroke on that, and then I can break this guy, and then all of the others that we try to pass to it can, once I get my semicolon in place, there we go. Look something kind of like that. All right, so there's our helper for the draw arrow function, and then we can go back over here. Where was I? I was over. Base load, base load, base load. That's the one I want. And now I can just do our drawing helpers dot draw arrow. And basically, so if W1 less than 0, we can do, I want all of these points still. And again, we're just drawing at the midpoint. So we'll want to update this eventually. Okay, else we want to do, put a draw arrow there. And then where is, what's the signature? The arrow directions we need to do. Arrow directions dot, for less than 0 we want the down, and then close that. Otherwise we want comma and then arrow directions dot arrow up will get me that one. There we go. And so that will get us our arrows for up and down. Now, obviously, if we start getting oriented, we'll have to revise this. That if we start putting one-input loads left and right on a building, then this will start to break down. What did we miss? And I didn't want to do that. No, what broke? Fall. Oh, can't fall out of a default. They told me that. All right. Put that in there. Okay. And so with that, I think we're in business. And so you can see we got our load. It's drawing it as an up because our magnitude was more up than down. So if I come in on this guy and say that instead it's a -5 and a -5 on this. And why didn't build? Clean the solution. Why is it not flipping around? It didn't flip. Alright, so where's my base load? Go to our point load. Did we miss something up here? Ah, and there it is, right off the bat. That should be a W1. Okay. Alright, those of you that saw that in the last video and were yelling at your screen, I hear ya. Okay. Got lucky, that was just the only one that was wrong. Why did that not? W1, W2. W1 gets MW1. Beam. Well, I guess it would help if I did W1 equals W1 and W2 equals W2 and D1 equals, let's stop it was defaulting to 0, D1 equals D1 and D2 equals D2. Should get us that hopefully will fix it. There it is. There's our arrow now drawing downward. Now again, graphical display position's a little wonky, but we will fix that. But okay, so now we have the ability to make those changes. So that's a little better way to kind of, again, we're just kind of evolving it a little bit. So now if we got an arrow left, how do we determine an arrow left? So we can kind of set our logic, you know, based off of that. But at the end of the day, the load knows what direction it needs to go based on its value. Okay. So let's see. So now if we come back in and we look at that, so, you know, if I were to change this to now positive and make that a positive and I run it, now you can see the arrows acting up. So it's, our helper is evolving, and that's kind of what helpers do, is they evolve over time to kind of save us some lines. Takes a little time to get them set up, but it's not bad. Okay. Yeah. So that resolves. So we've got our beam redrawn. Now we've got to kind of come in and start figuring out how are we going to do this index, this connectivity index. And so we've got the beams, and that connectivity index is basically the same thing as what we were doing up here in our beams object. Because we're taking our beam elements and we're throwing them in here, and every beam knows how it's connected to something else. All right. So what we want to do now is we want to kind of play with this a little bit, and I'm going to go in and I'm going to add another node. Okay. A VM node, and we're going to call that as node C. And we're going to say that's new, and then VM node. Let's put it at the halfway point, so 220, 20, and this is the support types, and it's going to default to the undefined node because it doesn't have a support. So we'll just do that, and then we'll do nodes.add node C. That gets us there, and then we're going to make a beam, and so the first beam is going to go from A to C, and then I'm going to copy this, Control C, and I do have a typo there, so we'll fix that. All right, and then we'll pull this down, and we'll now do beam 2 that now goes from C to B, like that, and then we'll add beam 2. Okay, so now we can go in. What did I miss? Oh, I see it already. This in my parenthesis. There we go. Hit that. And if we run it, so there's our, again, graphics a little wonky. The load's still on that first beam, so he knows he's over there, so it's updated itself. And so that's kind of our marker for that base node. And so we're still numbering things. We're still doing that all right. So now what we want to do is I want to add this load. Instead of putting on the first one, let's put him on the second one. Oops, insert, comma. There we go. So we're going to go grab the second one out of the list. And so now he's over on the other side. And so what we want to be able to do is work out what are his coordinates based off of the origin node here. So we've added directly to the list. And I think what's going to happen on this is that we've got to come in, we're going to need to define an origin. Yeah. So we got our mouse locations. Let's go through and do our public VM node. Not really the origin, it's more of a reference node. A reference node. And we're going to set it equal as null right now. So that initialized it. Okay, and this is the leftmost node on the structure. Okay, and so now where we were before coming in and adding nodes to our beams, once we go in and set our node, add our node to this node list, it needs to go through and set the reference node. So how do we want to do that? Do we make a method in which we now do I don't know if I want to do public on this. Can I do protected? Let's try protected for now. If that doesn't work, then we'll change it. So protected void, okay, add node, and then we're going to do a VM node node on that. And so what this does, oops, stop our debugging. And so we want to adds a node to the nodes list and updates the reference. So instead of doing a nodes.add, now we'll just do an add node function, which all it's going to do is it's going to do nodes.add a node. Okay, and then we're going to come in, and then it's going to update. It's got to go through and find all of our nodes. So let's do a VM node temp. Okay, and at that point we'll start it off at node 0, and then just simply do for each, and then VM node item in nodes. Okay. If item.x, okay, is less than temp.x, right, then temp becomes item. All right, now what do you do if the nodes are completely above each other? One is above the other and they have the same value. Okay. Okay, else, okay, if item.x is equal to temp.x, then here we'll take the lowermost. Okay, if item.y is less than temp.y, then temp equals item. Okay, else, and I don't need that, so let's get that out of there. Else if, okay, I got my parentheses in the wrong spot. Okay, otherwise we don't do anything, and that kind of structures our order on this. And that I need to cast. That's a VM node because it was an iDrawing object on that guy, so we have to cast him back. Okay, so that gets us our sorting, and then all we do is we set our reference node. Let's do a get set on that guy. I think we're okay with that. Do I need to notify anything when the reference node changes? Probably not. Okay, so we added our node, and then reference node, oops, reference node equals temp. Wow, where did my equal sign go? Looks something kind of like that. So that will help us get to the leftmost on this. Okay, now I need to find all references to add. Node. And so we want to do add node A. Probably not the best definition for, or best label for that, but I think it gets the idea. All right, and then everything else should be the same. All right, so that gets it. Now let's test to see if our on user update, let's draw a line from our reference node down to some arbitrary point. Draw a reference line temp. Okay, and we want to do drawing helpers dot draw a line, and then we're going to put it on canvas on main canvas, and my start node is going to be my reference node dot x, and then my reference node dot y is the start, and then the end we'll just draw a line off to somewhere 300, 300, and then we'll do brushes dot no, it needs to be a brush dot brush media, nope, brushes, and the color I want to just make it like a, again, just something to distinguish it. It'll look something like that, and that should get us that guy. All right, let's see. And so you can see that it found its order here. Now, here's the thing that the test on whether or not it's actually finding the thing. Let's move A, which is the one to the left, so that he's not the first. Let's move him down here, so that now he's the third one. And if I do that, it should still work. All right, so we're finding that reference node, the leftmost. And from this, then, we can start to kind of build out our pieces for working our way across the system. But we found the leftmost on our beam. So I think we'll go ahead and we'll stop it there. I want to keep these fairly short. So we're working out some sorting and getting into some of our first logic on how to draw these things and put these parts together. And in our next video, we'll come back in and we'll start trying to figure out, okay, can we get the coordinates of a load off of an object by now starting to splice these things together? So we'll have to kind of work our way. Again, there's some logic that's got to be involved with connectivity that, okay, I've got this node now. I can find the beam that I need to move across. So we're going to have to kind of play with that a little bit, because it's almost like a, like a directed graph almost, especially if I have multiple members coming into a node, that which one do I choose to move across, make a list of a path that moves across this thing to be able to find that point. And if I can do that, then I can come in and I can pick up all of my parts, and we can kind of start to kind of work our way through the graph based off of that reference frame, and I think we'll be in business as far as that goes. So we're getting into some kind of some weirdness on this one. So, as always, thank you for hanging out with me. We'll get this one up, and then we'll continue working on this over the next couple of days and see if we can kind of resolve finding these loads and at least getting that start point. Because once I get the points figured out, then I can start doing all the calculations, because if I can resolve everything into forces at points with unknown reactions at other points, I can write statics equations all day and the picture doesn't matter. And so that's kind of the idea of what I want to try to set up with this. This may be the wrong approach. We'll know pretty quick in the next video or two. So let's find out. So anyway, thanks for coming out. As always, if you found this interesting, think about giving us a thumbs up, subscribe to the channel, and we'll let you know when the next video comes out, hopefully in a couple of days. So thanks. See you all next time. Bye now.